The fascinating science of radio wave propagation is explored, demystifying how these invisible waves travel through the air and interact with antennas. We will explore the fundamental concepts behind radio wave propagation, offering a deeper understanding of how radio communication works. Radio waves are the invisible force behind our communications around the globe and beyond. Till recently, long distance communications across the globe depended on high frequency radio waves, of which the short waves were more important. They would go up from the radio transmitter and get reflected off the ionosphere, a special layer of the atmosphere which gets ionized by the sun rays. Now, with the presence of numerous communication satellites, the role has been taken over by very high frequency, ultra high frequency, and super high frequency, which are known in short as VHF, UHF, and SHF respectively. These waves do not get reflected by the ionosphere but go straight into space and hence need satellites to receive them and retransmit them to another part of the globe for facilitating global communications. The voice which we speak are converted to electrical signals and carried by the radio waves to the intended person with necessary equipment. Antennas are devices which convert radio frequency electrical signals to electromagnetic waves which travel at the speed of light, that is 300,000 kilometers per second. So it takes only a fraction of a second for signals to travel across the globe, facilitating almost instantaneous communication. But when the signal has to be relayed by a satellite, which is located at great altitudes of say 36,000 km, there can be a slight lag between the transmitted and received signals. Dipole antenna is one of the simplest antennas which can convert radio frequency electrical signals to radio waves as shown in the animation. It can be just two metal rods, each 1/4 of the wavelength of the resonant frequency, attached to a radio through a transmission line. While receiving radio signals, the oscillating electromagnetic fields cause movement of electrons in the antenna, charging the ends of the antenna positive and negative alternatively. The oscillating current produced thus flows back and forth through the transmission line to the radio. The radio extracts the audio signals from it and presents to us through the loudspeaker. The frequency of oscillation will depend on the frequency of the radio waves received and will correspond to the resonant frequency of the dipole for best reception. More advanced levels of communication like satellite communication need better antennas like the parabolic antenna shown in the initial illustration. Simpler antennas can be used if the satellites are located in the low Earth orbits like International Space Station. But the communication is possible only for a short period like 10 minutes, during which the satellite is above the horizon. Antennas are designed according to the purpose for which they are meant. Radio telescopes are huge arrays of antennas for receiving radio signals from extremely high distances in the cosmos. But ordinary radio communication does not need such huge arrays. The mobile phones which you have in your pockets have tiny antennas within them. Those of you who had used mobile phones earlier would remember that they had small projecting antennas which could even be extended for better reception. But now, with wider availability of cellular coverage with numerous relay towers, small antennas within the phone, usually printed on the circuit board, are enough. Still, Those who have traveled to remote areas would have faced the problems of signal loss in cell phones. That is because of scarcity of relay towers in those less populated regions. Fascinating field of radio waves is evolving fast with newer technologies being implemented regularly like 5G networks and wireless power transfer. Scientists are able to receive radio communications from Voyager 1 spacecraft, which was launched in 1977 and is currently traveling in interstellar space beyond the solar system at a distance of 24.9 billion kilometers from Earth. Radio signals traveling at the speed of light from Voyager 1 takes 22.5 hours to reach Earth. At home, radio waves have immense potential to transform our lives. Most of the equipment now at home, like computers, television, and numerous Wi-Fi enabled devices, including robotic vacuum cleaners, use radio waves in one way or another.